Oke, baik kita mulai ya perkuliahan untuk pagi hari ini ada deh ya. Sekarang sudah menjelang siang ini ya. Oke, baik. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Thank you very much for all of you who are right now watching this video. Hopefully, this material will give you some benefits. Yeah, will give you some insights about more insights about the advanced database. Yeah, or our advanced database course. Yeah. Okay. So students, today we're gonna discuss about the next topics in our course. Yeah. It is about the transactions and concurrency. Yeah. Okay. And this is our agenda today. So first we are gonna discuss about the basic concept of the transactions, and then also the transactions management in PostgreSQL, and how the locking and concurrency control mechanisms works in the PostgreSQL. And also, we are gonna learn about how to do some basic transactions, and also we want to simulate the transactions conflicts in the PostgreSQL. So regarding the last two topics, you can try it by yourself in the lab instructions that I will upload it in the Google Classroom. Yeah. Okay, so now let us go to the first concept. It is about the basic concept of the transactions. Okay, so what is transactions? So usually when you learn the word transactions, maybe you will imagine about something related to the maybe finance or maybe money, something like that. Yes, it is true in part, yeah, but actually in this database concept, transaction is more about the technical concept in the how in the database about how we execute some process. Yeah. So usually in a database we are running some ordinary SQLs. Those SQL will be executed by our applications one by one. Yeah, but sometimes there are also some complex business logic that needs more than one operations. Yeah. Maybe, for example, whenever this operation executed, it will be updating the more than one table. For example, you run the process and then the A table will be updated, and then after table A is updated, then it continues to update table B, and after that it will be updating the table C and also delete something from table D. That is what I mean by the complex operations of SQL. So instead of only updating or changing the data in one table, usually process like this will modify more than one table. And those process cannot be done partially. It means that whenever we have, for example, three operations updating table A, B, and C, it must be done in sequential, and all of these operations must be successful. So whenever one of the process is not success, then all of our process must be canceled. Yeah. So this is the concept of transaction. So we can use transaction if we want to do some process like this one, like I told you before, about the some specific processes that needs to be done in sequential and updating more than one table, and all of the operations must be successful. Yeah. So we can use this kind of transaction, this kind of operations, and this operation is called transactions. Yeah. So a transaction is a database, is a logical unit of work that includes one or more SQL, such as insert, update, delete, or select. Yeah, that must be executed in their entirety. So it means that all of the operations must be successful. Yes, there is no room for error, for even if it is just only one operation. So all operations must be success. If one or more of them are failed, then the entire operations must be canceled. Yeah. So this is what we call by transactions. So all comments in the transaction must be committed in their entirety, or if one fails, they are rolled back. Yeah. So transactions will ensure that data integrity is maintained even if there is a system error, power outage, or multiple users accessing the data at the same time. And also with the transactions, the database can guarantee that any data changes, not partial, no, or not halfway, and no overlap between users, and always generate valid data states. So to give you more clear understanding about what is transactions, you can imagine a case whenever you need to transfer your money to your friends, to your friend's account. Yeah. So how does the transfer work? So first, of course, the bank system will reduce some amount of money from your account. After that, those money will be sent again into your friend's account. For example, here your friend wants to borrow from you 50,000 rupiahs. Yeah. So what happened in the background? The bank system will reduce the amount of your balance uh, for 50,000 rupiahs, and after that it will transfer the money. It will increase the balance of your friend's account. So if we look at the database level, it is considered as two different operations. Yeah. So the first operation is reducing the amount, and the second operation is increasing the amount. And these two operations must be done sequentially. Yeah. So it cannot be failed. Yeah. It cannot be done number two first and then number one. No. So it must be done in sequential. So operation number one first, and then operation number two. Yeah. And secondly, these operations must all of them must be successful. So there is no room for error for only one operations, yeah, or even two of them. It should not be any failure. So if there is some error, we must cancel all of the operations. Yeah. So whenever if we're not doing something like that, so what will happen? So for example, whenever the bank successfully reduce the amount of your balance around 50,000 rupiahs, and then the bank will do the second operations to increase the balance of the recipients. Yeah. So whenever the operation number two is failed, what happened? So your friend does not receive your money, yeah, and then you already lost your money. So this will be disastrous. Yeah, see, this will make us feel not good, right? Because we lost some amount of money. So this is what we call by the atomic transaction. So it is all or nothing at all. Yeah. So another example, for example, is about the online shopping transactions. Yeah. So for example, when a user buys something from online store, the store system will reduce the number of stock of those purchased items. Yeah. Then after that, the item will be added into the order table. So into the customer's transaction list. After that, the system will create the invoice in the financial system. So these three operations must be successful. All of them must be successful. If there are one or more operations become failed, yeah, then all of the operations must be canceled. Yeah. This is called as rollback. So we update the system, but something failure happen, then we cancel the operations. It is what we call by rollback. Yeah. So this is some examples, yeah, some examples of real world, yeah, real world case when we can employ the transaction feature of our databases. Ya. Oke, jadi adik-adik ya, saya bantu jelaskan pakai bahasa Indonesia. Transaksi itu adalah, ya, transaction itu adalah suatu fitur di mana kita bisa menjalankan suatu operasi itu secara bersama-sama, ya, secara bergiliran, secara urut, dan harus berhasil semuanya. Kalau tidak berhasil semua, kalau ada yang tidak berhasil, baik itu satu atau lebih dari satu, maka transaksinya dibatalkan, maka operasinya dibatalkan, data dikembalikan seperti di awal. Itu yang saya maksud dengan transaksi, adik-adik ya. Nah, contohnya seperti transfer ke bank, ya, di mana ketika kita mengirim uang, Mengirim uang itu berarti kan saldo kita dikurangi dulu. Terus kemudian saldo orang yang kita kirimi ditambah. Nah, ketika saldo kita berhasil dikurangi dan kemudian saldo orang lain tidak berhasil ditambah, maka uangnya kan akan hilang. Ini akan menimbulkan kekacauan. Nah, hal-hal seperti itulah yang bisa dicegah dengan menggunakan transactions. Ya, oke. So this is the analogy of real world implementation of transactions. And so if we are talking about the transaction, we will find some word, we will find some words that is containing the key principle of the transaction itself. So those words actually usually will be abbreviated as the ACID. Yeah. So ACIND. So what is ACID? Stands for atomicity. So this is meaning that all of the steps in our transactions must be successful. If there are one or more steps is incomplete, then the operations cannot be proceed at all. So the operation should be cancelled and the data must be brought back to the initial state. And then the next word is the C, or consistency. So one transaction is complete, so the data remains consistent, and it is it is also always have in the integrity. Yeah. So the data must be there. The data must be there, and then the data must be true, must be correct. Yeah. This is what we call by consistency. And also the I is isolations. So transaction runs separately and do not interfere with each other, even though they are run simultaneously. So the I is the another concept of the transactions. Whenever we are running the transactions, the operations is done separately, and it is not interfering with the other transactions, even though the operations are similar. Yeah. And then the last word is D. It is about durability. So after commit, so if we are running a transaction, there are some times when we need to call commit, comment. Yeah. So after the comment, the transaction results must be stored permanently. And even if the power goes out or the server is done, whenever it is started again, the data must be there. So it is about the ACID, ACID. So A means atomicity, C is consistency. The data must be consistent. The data must be having their own integrity, and also I is isolations. So the transaction operation is done independently, not interfering with any other operations. And also durability, the data, whenever we call commit, whenever the transaction is done, whenever the transaction is finished, the data must be stored permanently in the database. So ACID ensures that database transactions are reliable, secure, and predictable, even in complex multi-user conditions. So this is a simple example of transactions, some simple example of transactions in the PostgreSQL. So this is how we write transactions. So for example, this is about the money before, about the money transfer before. So whenever we want to transfer 50,000 rupiahs money from our bank account, the bank system will do two separate queries. So if we are doing those queries inside a transaction, so we must write it something like this. So first we will write begin. Begin meaning is the place when the transaction is start. So first the database will execute this one, update reckoning set saldo equals to saldo minus 50,000, where ID equal 1. This is, for example, the user ID who is sending the money. And then after this is successful, the database will execute this second operations, the second statement. So this is update reckoning set saldo equals to saldo plus 50,000, where ID equals 2. This is the ID of the users who is receiving the money. So both of these transactions will run correctly. So after this two operation is complete, then we call commit here. So the change in the database is implemented permanently in the storage, in the disk. Okay, so both command will be executed successfully. The data is stored permanently. So this is update. This one is success. The second update is success. After that, the data is committed into the folder, into the database. Yeah. Okay, so this is the first example. And what if the transactions is error? What about how if the transaction is incomplete? Yeah. So for example, here, whenever we are running these two operations inside a transaction, something like this, begin, and then update reckoning set saldo. This is correct, yeah, because this is valid value. And then after that, we have second operations. Update reckoning, set saldo equals to saldo plus ABC. So this is, of course, will give us an error. Yeah. So what happened is something like this happen. For example, maybe whenever the system bank is being hacked, yeah, or it is being injected by SQL injection. So the operation is failed. Yeah, operation is failed. So which one is better? Abort all of the operations, or let them be, let the successful operations proceed, and then let the fail operations stop. Yeah. So which one is better? Let one of them success, or let no one of them success. Yeah. Or cancel all. Yeah. Cancel only the one is failure, or cancel all operations. Yeah. Which one is better? So of course the answer is, whenever we are having some error with one of these operations, it is better for us to cancel our operations, to revert back, to make the data become as the initial state, yeah, to reset the data back into their original states. Why? Because if we let this operation success, yeah, so meaning that the user one who are transferring the money, he will lose the money. But the user that is should be receiving the money, he or she is not receiving the money. So the money will go away, will fly away. Yeah. So this is not good. So that's why we need to call a rollback. Yeah. Something after our transactions is finished. Yeah. So we need to call a rollback. If the transaction is not success, then we roll back the transaction. Yeah. So whenever we are calling rollback, then the data will be restored to the original state. Yeah, it will be back into the original state. Yeah. Okay, this is one simple example of transaction in PostgreSQL. So from that example, we got some important notes. Yeah. First one is begin. So if we want to do some transaction, we have to put our SQL, our operations, after the begin statement. Yeah, begin statement. This is marking the beginning of a transactions. And then if we are sure that our transaction is already finished and it is successful, no problem when we are executing it. Yeah. So at the end of the transaction, we have to call commit. Yeah, commit. This commit will save all change inside a transaction. Yeah. And it will make the data change become permanent. And the third one, we have rollback. So we can call rollback if our operations is failure. Yeah. So if our transaction is not finished accordingly, we can call rollback so the data can be brought back into their original state. Yeah. So this is the rollback. And then we also know that PostgreSQL is automatically rollbacks if an error occurs in the middle of a transactions. So it will automatically call rollback. Then we go to the second topics. This is about the transaction management in the PostgreSQL. Okay, so PostgreSQL provides three main commands for handling the transactions. Yeah, I already explained it in the previous slides. Yeah. So begin is when we start the transactions. Yeah, it's the place when we start the transaction. After begin, you can write the SQL statements that are needed for your operations. After that, if your operation is success, you can call commit. Yeah. And if there are some process that may be gone wrong, yeah, we can call rollback to revert our data, to get back our data into its original state. Yeah. Okay, so PostgreSQL doesn't directly store the results of its HTML comment. Yeah, so this is what another important thing that you have to understand. So students, whenever transactions is called, before the transaction is committed, before you call commit that, then the change will be stored temporarily. Yeah, temporarily. Yeah. So it is not directly written into the database or into the storage. Yeah, but for example, when you execute the previous query, yeah, so update balance, yeah, you change the balance of an account. Yeah, so you subtract, yeah, the balance by 50,000 rupiahs. Those change whenever you select it, yeah, select all from the balance, for example, from account where user ID equals to 1, for example. Yeah, so the balance is subtracted. Yeah. For example, you have 1,000 rupiahs, yeah, and then it is subtracted by 100,000 rupiahs, yeah, and then it is subtracted by 50,000 rupiahs. So it's still 50,000, right? But if you are using transactions, if you are using original ordinary SQL statement, the data will be directly changed into the database, into the storage. But if we are using transactions, those value 50,000 rupiahs since left in our balance, it is actually only temporarily. Yeah, it is stored in the memory, not written permanently in the database. Yeah. So when it will be written whenever it is successfully executed. Yeah, all of the operations are successfully executed, and then we call commit. Yeah, we call commit this one, this commit comment. So the data will be finally written permanently into our storage. Yeah. But if it is end with rollback, so all changes will be undone as if they never happen. So if we call rollback before we call commit, if we cannot reach commit and then we call rollback, the data will be the all of the changes will be undone. It will be back into the previous state, into the original state. Okay. So there are important concepts in transaction management. The first one is begin, commit, rollback. This is one. This is three important words, three important keywords in the PostgreSQL that you need to remember. So we start the transaction by calling begin, and then if the transaction is finished, successfully finished, all of the operations is successfully finished, then we call commit. Yeah, and then if we are unable to reach the commit, then meaning that something happened, something not good is happening, so we can call rollback, and then the data will be the changes will be undone. And then also the atomicity principle. Yeah, this is on a practical level. If related changes, yeah, if there are the related changes must be done together, all of them. Yeah. For example, whenever in the final project, ya, system case, ya, whenever an advisor, ya, or a mentor, ya, or mentor giving changes in the proposal, ya, and then he or she will add some notes, ya. Those changing in the proposal and those changing in notes must be work together. If there are one or more operations inside of that block is fail, then all of them must be cancelled together. Yeah. Okay, and then the next one is the error handling. So one error, if an error happening, so the transaction will become aborted. Yeah. So we need to call rollback to cancel the any successful operations. And also cross table consistency. So transactions can keep the table involved in sync. Yeah. For example, if the topic of the proposal and other entities in a single, if the, for example, the topic of the proposal and other entities in the single transaction. Okay, I think this is and some mistranslation in these sentences. What I mean is that if you are doing some operations that is involving more than one tables, for example, three tables. So the changes in these three tables must be synchronous. Yeah, must be uh, must be correct. Yeah. Whenever you add something to the table A and then you update something in table B and then you delete something in table C, those three different operations must be done correctly so that all of the data is clear. Yeah, the data is clear. There are no confusions. Yeah, for example, in the table A, the data already added, but why in the table C, the data is still there? It must be deleted, something like that. So this is hard to keep. Yeah, if you are not using transactions. Yeah, if you are using just simple query, you have to execute three separate query. Yeah, to update table E and then check the result. After that, if it's okay, then update table B, and then if it is okay, then delete table C, for example, something like that. Yeah, it will become more difficult. Yeah, more difficult if you are not using transaction. If you are using transaction, you can wrap all the operations into one functions. Sorry, not functions. Maybe one trigger or one stored procedures, and then for your source code, for your application source code, you just call the name of the transactions. Yeah. So for example, call update proposal, done, and then the transaction itself will do the work. Yeah, and then you will got the consistency. Okay. So this is the first one is about the atomicity. Yeah, for example, whenever a lecturer revises one proposal, changing the descriptions and adding the for example, special message or catatan khusus. Yeah, special notes. Yeah. Okay, so these are two process. Give revisions, yeah, give revisions, and then the second one, give a description, changing the description. Yeah. So this must be done together. This must be all of these operations must be successful. If one user successfully revises one proposal, but whenever he is adding nodes, yeah, the system is failed. What happened? So the proposal is there is some confusion, yeah, whether the proposal is already revised or not. Yeah, if it is already revised, then where is the notes? Where is the special notes? Where is the catatan khusus? Yeah. So this will become dangerous. Yeah. This is will be confusing for the user. Yeah. So instead of doing separate update for the proposal and also catatan khusus column, we can combine it. Yeah, we can make it into one maybe store procedure or maybe trigger. Yeah, and then we put it inside transactions. Yeah, for example, something like this. So begin and then update proposal, set deskripsi, revisi, tambahkan evaluasi baseline dan skenario uji, and then catatan khusus revisi sesuai arahan pembimbing pertemuan kedua, where proposal ID equals to 1. Now, then after that we call commit. So that if there is a problem, for example, whenever we update it, yeah, for example, this one we are updating lab ID. We don't have lab ID XXX. We have if IVSS or we have DT, something like that. We don't have XXX. So whenever we are changing the proposal lab into the unknown lab, this will become error. So if we are not using transactions, then the previous transaction that is already success will be stored. Yeah, will be stored permanently. But we have some inconsistencies. Why? Because our operations there is still some failures. Yeah. So to prevent that, we can put it into begin, yeah, into begin statement. And if we find it is fail, then we can call rollback, yeah, to make the to return to the data into the original. All right, now let's continue to the next important topics. It is about the sequential transactions. Yeah. So this is one example when a transactions needs to be done sequentially. Yeah. So for example, we want to assign a mentor to a specific proposal and mark the internal nodes. Yeah, so we have two steps here. One is assigning a mentor into a specific proposal, and the second one is to mark the internal nodes. These two steps must be succeed together. Yeah. For example, this one, so this is the first operations, the first update statements, and then this is the second update statements. So this is one example of the sequential operations. Yeah. those operations must be done correctly. First, number one first, and then number two, and all of them must be succeed. If one of them is failed, then entire operations must be cancelled, and the data must be reset to the original state. So this one is updating the supervisor or the pembimbing. Update proposal set dosen pembimbing 1 ID equals to 4, where proposal ID is 3. So first we assign supervisor, supervisor with ID 4. Then after that we put notes. This the name of the supervisor is this one. So Dr. Dewi Lestari, for example, where the proposal ID is the same 3. So if in the step 1 we will fill the dosen pembimbing 1 ID that is not in the lecture, so foreign key will fail. For example, if this in this one, in this step 1, if we wrongly put different lecturer ID, for example, we have put here dosen pembimbing 1 ID equals to 400, for example. So we don't have lecturer with ID 400. So what happened? This will be failed. This operation number 1 will be failed. So what happened in the with the second operation? The second operation will not be done, because this is transactions, because we have begin here and then commit here. So these operations, if this one is failed, then the second one will not be proceeded. So all of the entire of the operations, or the entire operations will be canceled. So what if the entire operation is not canceled? What if we let the second operation succeed? What will happen? So the data will not having their integrity. The data will be confusing, especially for the humans. So if the first operation is failed, meaning that this proposal, the proposal with ID 3, is not successfully given any supervisor, because we don't have supervisor number 400, right? So but the second operation is succeed. We put here the notes that the supervisor for this proposal is Dr. Dewi Lestari, for example. Then whenever the lecturer or the administrative staff looking at the recap of the proposal, it will become very confusing. Why? Because this proposal doesn't have any pembimbing, doesn't have any supervisor. But why in the notes it is said that the advisor is Dr. Dewi? So which one is correct? This is one example, some confusion that will occur when the data is not having their integrity. Okay, so this is the example of the sequential transactions. Then what happened if a transactions fail? What happens is if one or more operations inside a transaction are failed. So by default, the operations will become will be cancelled. The operations will not be written into permanently into the storage. For example, this one. Begin update proposal, set lab ID equals to IVSS. So this in this operation we are changing the lab of a certain proposal. Because IVSS exists, then this operation is okay. And then update proposal set dosen pembimbing 1 ID equals to ABC. So this is wrong, wrong data. So this operation will be error. And then the third one is update proposal set catatan khusus, catatan tambahan pasca error. This is this will not be executed. This will not be executed because we have 1, 2, 3. Because we have 1, 2, 3 operations, and operation 1 is success, operation 2 is failure. Then the next operation will not be done, will not be executed. So that's why this catatan tambahan pasca error, catatan tambahan, this one will not be saved into the database. Why? Because the transaction is aborted. By default, transactions will be aborted, will always be aborted whenever failure happening in one or more operations inside those transactions. Okay, so this commit will not be called, because this one is failure. As I mentioned before, in a transaction, all operations must be success. If there are one or more that is not success, then all of them must be canceled. Yeah. So this commit will not be called. This commit will not be called. So instead of calling the commit, yeah, we have to call rollback. Yeah. Somewhere in our code, we need to put rollback. Maybe you can put it in the exception, for example, or maybe you can input it into your application function. Yeah, application function you call rollback, for example. Yeah, that one is also okay. Yeah. So it is important for us, yeah, for you, yeah, to always put rollback, yeah, somewhere within your code whenever your code is failing. Yeah. The best way to put this call rollback is, of course, in the exception block, yeah, as we already learned in the previous material, yeah, in how to handle error. Yeah. So if we are not, if transactions, if a transaction never reach commit or never get rollback, yeah, what happened? The data will be locked. The data will be locked. The table will be locked. Yeah. We cannot update this data until we complete this transaction. Complete here consists of two conditions: complete successfully or complete failure. Yeah. So whether it is success or fail, we have to end the transitions. Yeah. If our transition is failed, then we should end our transition by calling the rollback. If we don't call rollback, then the other operations cannot be done into the table. Yeah, it will cause error. So it will prevent any user to update those record. Yeah. Okay. Then the next one is the importance of data consistency or cross table. Yeah. So transaction objective is to maintain consistency between tables. Yeah. For example, in the topic, proposal, lab, students, or lecture. Yeah. So I will give you an example here. When a topic is declared complete, so all related proposal are given a synchronous note. Yeah. So here in our department, so whenever a student want to do their final project, they must have a topic. Yeah. Then after they create and after they have a topic, then they create their proposal. After that, their proposal is will be discussed, yeah, will be discussed by the lecturers, yeah, and then the proposal will be given one of the two status. Yeah, the first one is um, pass, yeah, pass. So the proposal can be continued to be final project, and then the second result is fail. Yeah, so the proposal must be revised. Yeah, must be revised, and the students must have discussion session again. Yeah, with the lectures. Yeah. Um, in this case, yeah, in this case, this operation will involve at least two tables. At least two tables. The first one is the topic tables, and then the second one is the proposal table. So whenever a student got past status from the proposal seminar, yeah, for the proposal seminar sessions, the topic must be updated. Yeah. The topic status will be updated as done. Yeah, is updated into done or finished. Yeah, and then we take a note in the proposal that this topic, yeah, topic number 5 is finished, is passed. Yeah, it can be continued to be do in the to be done in the final project, yeah, final project phase. Yeah. So this will be somewhat difficult if you don't use transactions. So if you are creating a system that is doing something like this one must be okay, this one must be okay. Yeah, what you will do, you will write you will write two different queries, yeah, two different statements. You will execute the first statement and then you will execute the next statement. Whenever the first statement is success and the second statement is not success, is failed, yeah, then what happened with the first statement? This will be directly written into the table. So this is what I mean by the halfway operations. Yeah. So the operations is only be done in half. Yeah, not fully complete, only partially complete. Complete. Yeah. And this is dangerous. This is dangerous for applications that is having the complex business logic. Yeah. For example, like finance applications or healthcare applications. Yeah. This can be dangerous. Yeah. This can be dangerous for users and also for you also for the developer. Yeah. So we can prevent this one by using the transactions. If this one is success and this one is failed, the data will be reverted back because it is better for user to know that something that they done is failed, yeah, then letting the user the some operations is success and then some other is fail, and letting the user thinks that they thinks that the operation is success. Yeah, this is dangerous. So making the user think their operation is success is not is not better. Yeah, it's not any better compared to letting the user that their operations is fail. Yeah. So it's better for me if I know whenever I do something and then fail. So I just need to repeat it again. Yeah. Compared to when I think that my operation, that something that I will do is okay, but actually it's not okay. Yeah, this is very dangerous. Yeah. So we can prevent this one. We can keep the consistency by using the transaction. Yeah. All right. Yeah. So the next topic is about the locking and concurrency control. Yeah. So in a real system, usually the user will be so many. Yeah. You maybe we don't know in the future. Maybe you will work on a system that is used by maybe hundreds of users, yeah, or thousands of users, or even millions of users. So those many users, it is very possible some of them are accessing the same, yeah, accessing the same operations, doing the same operations in the different or the same data. Yeah. So what happened if if two users, yeah, doing updating something, yeah, in the same row, yeah, what will happen? Yeah. If we don't control, if we don't manage those operations, those concurrent operations, those parallel operations, there will be a conditions called race conditions, yeah, or overlap. Yeah. This is very dangerous because maybe the data that is updated by the first user will be overridden, will be overridden by the data from the second user. Yeah. So this is what we call by overlap or race condition. In order to prevent this case, the PostgreSQL employs some technique called locking. So the PostgreSQL will lock the resource, will lock the rows, row, maybe table, it can be row, it can be table, whenever a transaction is not finished. So whenever a transaction is not finished, any other user cannot do their update, cannot do their operations. This is what we call by locking, locking for concurrency, locking and concurrency control. So lock here will guarantee that only one transaction at a time can modify a particular line. Okay, so there are two types of lock in the PostgreSQL. The first one is row level lock. The coverage is only line that is being changed. So if we want to update a particular line using transactions, those rows only will be locked. But the other rows, it's not locked. It's not locked. So it will be able to be modified by the other users. Then, for example, here, when one lecturer updates one specific rows of proposal record. So when a lecturer updates a specific row in a proposal table, other lecturers cannot update those the same line. So the impact will be other transaction can still read or change the other lines. Then the next type is the table level lock. So this kind of lock will lock entire table. So whenever the transaction is not complete, other users will not be able to modify the lock table, entire rows in the table. Okay, so this is the two types of lock, row level lock and then table level lock. Okay, here is some example for you. So there are, maybe this is a scenario. So lecturer A, Dr. Dewi Lestari, for example, is updating proposal number 3 notes. So for example here, update proposal, saya catatan khusus, revisi, tambahkan studi komparatif dengan model lain. where proposal ID equals to 3. So at this time, because in this query there are no commit and there are also no rollback, this means that the transaction is still not finished. So whenever other user or other lecturers may be trying to update the same proposal, it will not work. The lecturer B will get prevented to update the same line. Because di situ update proposal, set catatan khusus, revisi, tambahkan uji performa tambahan, where proposal ID equals to 3. Because the proposal ID is equal to 3 and the lecturer is not finishing their transactions, so the the change by lecturer B will not be implemented into the database until the transactions of lecturer A is finished. Okay, but the operations of lecturer B will not fail immediately, but it will be waiting. It will be blocked until the lecturer A makes a commit or rollback. Okay, then it is the one example of table level lock. So for example, usually when data is getting bigger and bigger, the system will be slow. To prevent the system becoming slower, then some data will be deleted. So here, for example, our department admins wants to prevent any changes when processing the data recap. So for example, here our admins want to delete all the proposal that is having status, for example, is rejected or ditolak here, rejected. So begin lock table proposal in exclusive mode. This is how we can lock a table. So lock table proposal in exclusive mode, and then we can run the operations, delete from the proposal where status ditolak. So this is usually taking some amount of time. In that some amount of time, any other user cannot modify and read this, cannot modify those table until our admin calls commit here. So if it is commit already reached, then the lock will be open. The lock on the table will be open. So the table level locks are rarely used in ordinary applications. Usually it will be rarely used, and they are usually used for batch operations or system maintenance. This is about the table level lock. Okay, then there are also situations called conflict. So conflict will happen whenever there are two different sessions that is accessing each other locked row. So for example, we have two sessions. You can try to have two sessions in your local computer, in your PG admin, by opening two different tabs. You open tab 1 and then you open tab 2. And then you execute SQL in tab 1 and also you execute SQL in tab 2. You will run two different sessions in your PostgreSQL. Now, so for example here, okay, so for example here, we have in the first session, we update a proposal with ID number 2. Because we don't call any commit or rollback here, so the transaction is still not finished. The transaction is still ongoing. Because the transaction is ongoing, so this row is locked. After that, in the session 2, we run this also. Begin update proposal, set catatan khusus, menunggu revisi tambahan, where proposal ID equals to 2. This is also the same. So this session is still doing some transaction, and also this second transaction also doing transaction that is still not finished by transaction 1. So each session will be waiting. So it is called by conflict. So session 2 will wait because line proposal ID 2 are being locked by session 1. Once session 1 is commit, session 2 can only proceed and change the data. If session 1 and session 2 both lock different rows and then try to lock each other's rows, then a deadlock can occur. So if deadlock occur, SQL will automatically detect the deadlock and giving the error message, error deadlock detected. So if the example is like this, the deadlock will not be happening. Why? Because this is locking one table, one row with ID number 2. And in some times, this will be finished. So if it is finished, then this will be done. Yeah. So there is no problem. There will not be any conflict. But if, for example, this one is updating, updating a record that is currently updating by the session 2, and then the session 2 also updating a record that is currently updating by session 1, this will become conflict or deadlock. Okay, the next is about the multi-version concurrency control or MVCC. Yeah, so PostgreSQL doesn't rely solely on lock mechanism. So other than lock mechanism, PostgreSQL also has a feature called the MVCC or multi-version concurrency control. Yeah, so whenever a row is updated by using transactions, actually the database will store the history, the history data of the transactions. Yeah. So we have multiple versions of row. For example, first, we have in the proposal code number 3, the notes said that the notes said something like ABC, ABC. So proposal number 3, the notes is ABC. And then we are having some transition to change the notes from ABC into DEF, for example. So in the same line, proposal number 3, we change the nodes into the DEF, for example. So previously it was ABC, and then right now, whenever we are doing a transition, we change it into DEF, for example, something like that. What happened when our transition is not complete, still not complete, but other user selecting the same rows, what will happen? Yeah. So the other user will still be selecting the same row, but it will show, the database will show them the old value. Yeah, before the transaction is committed, so the old value will be given to the user. Yeah. So this is what we call by MVCC. This is because we have version. Yeah. So the previous versions and then current versions edited by the transaction. So this is what we call by MVCC. Yeah. So each row or tuple have several versions. When a single transaction updates data, PostgreSQL creates a copy of the new version without immediately deleting the old versions. Yeah. And readers by using select can still see the old consistent version until the authors of transactions completing their transactions. Yeah. Okay, so whenever transaction is still occur and then other users selecting the same data, the data will be the old version of the data, older version of the data will be given to the select, to the readers, to the reading users, with the select statement. Yeah. But whenever the transaction is complete, the transaction is called commit comment. Then whenever any user select again the data, the result will be the newer versions. Okay, by doing this mechanism, there will be some benefits. Yeah, there are the first one, select when the line is being updated. So the other user can still select the data whenever those data is still being updated. So they don't have to wait. Yeah, they can read the old version or stable snapshots, and then it can also doing update at the same time. The second transaction waits until the first transaction completed, and it can avoid collisions. And then after commit, the old version is deleted, and the new version become the official, become the data that will be shown by any user that is running the select statement. Yeah. Okay, this is about the multi-version concurrency control. Yeah. And this is a simple example when MVCC will be activated by the PostgreSQL. So whenever we are beginning some transaction like this one, so begin update proposal set catatan khusus sedang direvisi where proposal ID equals to 1. We don't call any commit or rollback here. But other user call select catatan khusus from proposal where proposal ID equals to 1. So the same ID, the same ID. And what will get by the what thing will be given to the reading users, so the reading user will be given the old version, the old version of the data before the catatan khusus is updated, before sedang direvisi. So this is one example when MVCC will run. So this is just information. So we don't do anything about this MVCC. It is I just inform you that in the PostgreSQL we have something called MVCC that allows us to read data that is still being updated by transaction. Okay, so finish the theory parts of this meeting is finished. Then let us now try some transaction, yeah, in pgadmin. Yeah. Okay, let me change to the pgadmin. Okay, so now I have opened my pgadmin 4 and I want to give you some example of how the transaction is working. Yeah. So, okay, for example, we have something like this one. For example, in here in the Sistem Tugas Akhir database, we have this one, yeah, proposal table, yeah. Okay, so let me see the content of the proposal table. Select all from proposal. Okay, so we have this many columns. And now I want to change the, for example, this one, yeah, catatan khusus. Yeah. Why I choose this one? Because this is a short, yeah. Okay, so I want to change the content of this catatan khusus for particular proposal ID. For example, here I maybe want to change proposal ID number 4, for example, yeah. So select proposal ID and then catatan khusus from proposal where proposal ID equals to 4. Okay, yeah. So I want to change this this column, yeah, this column. And then we have also select topic ID, right? Okay, topic ID. Okay, okay. So a particular proposal must always have particular topic ID, yeah, topic ID. So the concept is whenever a proposal is already tested, already discussed by the lecturer, and it is declared as passed. So the topic status must be finished, must be changed into finished. Yeah. Okay, so let me see the topic. Select topic. Select all from topic where topic ID equals to 5, right? Because this proposal number 5, the topic ID is 5, yeah. Proposal number 4, sorry, the topic ID is 5. Topic ID equals to 5. Okay. Okay, so I need to see the status. Nah, status, this one, yeah. Okay. Topic ID and then status. All right, this one, right? So we try, we assume that, for example, in this case, yeah, in this case, the proposal number 4 is already tested, yeah, already discussed by the lectures in the proposal seminars, yeah, in the proposal seminar. So here in the information technology department, whenever we want to determine whether students they can go to the next phase of their final project work, yeah. We need to conduct some seminars, yeah. In those seminar sessions, the students will present their idea, will present their proposal, and then it will be determined by the lectures whether this idea is valid or not, or this idea can be executed or not in the time span of the 1 semester, yeah. If this proposal is passed, then the status must change. The status of the topic must be changed, yeah. When a proposal is passed, the status of the topic of its topic must be changed into past also. Okay, so now we change the topic ID, this one, the topic ID 4, yeah, and then must have a topic. And in this case, the proposal number 5 topic is topic with ID 5. Okay. So we have proposal number 4 and number 4. So right now it is still not discussed, still not passed. Yeah. And then in this scenario, yeah, for example, yeah, this proposal is already presented by the authors, yeah. And then the lecturers considers this proposal is good, yeah, and then giving the status passed into this proposal. So we need to change the status of the proposal, right? So update proposal, set catatan khusus equals to already presented and declare pass. Yeah. Okay, yeah. So this proposal is already passed. Yeah. This is a good proposal. And then next we want to change the status of its topic. So the topic is in the topic table. Yeah. So update topic set ya. Set catatan khusus. Catatan khusus means special notes ya. Catatan khusus equals to pass ya or finish. Okay ya. So this is how when we are not using transaction, we just write two different queries. First one is to update the proposal table, and then the second one is to update the topic tables accordingly. Yeah. So I forget to put the where, right? Where proposal ID equals to 4, and this one is where topic ID equals to 5, yeah, something like this. Yeah. So this is what we do whenever we are using only ordinary or default, yes, or common queries. Yeah. When we are not using transactions, this update must be first we done this one, yeah, either by using pgadmin or either by using PHP or other programming languages, right? So we send this query to the database, and then if it is okay, then the result will be written directly into the database, and we cannot revert back. Yeah, we cannot revert back unless we are creating some queries to change the data explicitly. For example, we put back the previous value by using the same update statement, for example, something like that. Yeah, but when we are using the transactions, we can roll back. We can roll back the change. Yeah. Okay, so I will show you. Yeah. So we put here begin. Then at first we can see here the topic is still diajukan, ya. The topic is still diajukan, and then the proposal is also, the catatan khusus is still butuh data penjualan real, ya. Okay, now we are using transactions to update this catatan khusus on the proposal, something like this, ya. So I execute this one. Okay, topic does not exist. Okay, sorry, I forgot this column name. Yeah, this must be status. Okay. Okay. Okay, so now I update these two tables by using transitions. I call this one. So update one query written successfully in 30 milliseconds. Yeah. Now I want to check this one, the proposal table. Okay, now the status is already presented and declared pass. Yeah, something like this one. already presented and declared pass, correct? And then I want to check the topic table. Uh, the status changed into finish. Yeah. Okay, so because here I am not calling any commit or rollback, the rows of topic number 5 and also proposal number 4 is being locked by the PostgreSQL. So it means that when I open another session uh, of query tool, yeah, for example, I'm gonna right click here and then opening query tool. Yeah, this is the other session of query tool. So when I'm updating the same table, for example, I will update this topic table. Yeah. I change the topic into already finished. Yeah, for example, something like this. Because I haven't called any commit or any rollback, yeah, let us see what happened. What will happen. Okay, so the query is delayed. Yeah, the query is what we call postponed. Yeah, this is not immediately failed. Yeah, but it is waiting. Yeah, it is waiting. This is what I have already told you before about the lock, right? So whenever I'm in the previous session, in the session that is doing transactions, I'm here calling the commit, for example. What happened? When I'm here calling a commit, yeah, call commit, yeah, then you see here the second operations is also done. Yeah. So this is what we call by the concurrency control, yeah, locking. So the second in the first, because before, yeah, in this session, in the first session, the transaction is still not finished, then any operations in the same rows will be waiting, yeah, will be postponed until the transactions in the first section is finished. Yeah. This is what we called by the concurrency control, locking and concurrency control. So now I want to show you whenever a transactions get rolled back. Yeah. So here, for example, I'm creating another transaction. I'm creating here another transaction. And now I wanna, for example, this one, where topic ID, hmm, okay, where proposal ID equals to 4 and topic ID equals to 500, for example. Yeah. So I know in my table there are no topic with ID 500. Yeah. So this will be failed. Yeah. Okay. So now let let us call this transaction. Yeah. What will happen? Uh, Now it says the data. Yeah. Already presented. Hmm. Okay, I change it to be like this, yeah. The catatan khusus, and uh, I'm changing it into done. Yeah. Okay, so here I will run two different operations. First one is to update the proposal table, and then the second one is to update the topic table. Yeah. So let us see the initial value of both tables. Here. Okay, so yeah, already presented and declared pass. Yeah. And then the topic is this one already finished. Yeah. So now I want to change the same proposal, the same proposal. The proposal I will change it, the notes I will change it into, I change it to be like this. Yeah. Or I will change it into this one. Blah blah. Yeah. Something like this one. Yeah. Uh but I think this will be error because we don't have topic ID 400, right? So Now when we are not using transaction, what happened? This will fail, yeah. This will fail, and this one will be successful. Yeah, this is what I call what I mean by the halfway, yeah, halfway transaction, yeah, halfway. So only successful in partial way. Yeah. So now let us see what will happen when I execute this one. Yeah. Why it is success? Do I have a topic ID 400 or 500? No, 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 actually. All right. Okay. So I'm sorry. Yeah. This operation is success. Yeah. Because this is updating proposal to change. Yeah. Not update actually. This is because I put here topic ID in a where statement. So this is not changing the data. Yeah. So for example. I change it into this one. Ya. Set catatan khusus, bla bla, and no no, and this one ya. Okay, so I change the topic ID of the proposal ID 4 into 500. Yeah. If we are not using any statement when we call this one is error, right? Syntax error, the end of it. Sorry, this one. Yeah, this one. Okay, ya. Nah, when I execute this one, current session is aborted, command incur into the annotation block. Okay, I will call rollback first. Okay, ya. Nah, I know this transaction will be error. If I'm not using transaction, I'm not highlighting this begin statement. Yeah. This one. Instead of table proposal violates foreign key constraint. Yeah, this is error. Yeah, this is error. And this is not error. Yeah, this is not error because there is no problem. Topic ID 5 if exists, is exists. Yeah. Okay, so now I'm using the transition. Okay, so when I'm using a transactions, this transaction is not successful because one of those two operations is error. Yeah, this one is error. Update proposal set catatan khusus is error because there are no topic with ID 500. Yeah, this is error. Yeah, and what about this one? Is this still be called or no? Yeah, because we are using transaction, this is not be called. Let us see the topic status of the topic with ID 5 is still like before. Yeah. Okay. ID topic 5. Oh, okay. Sorry. Yeah. So this is get blocked. Yeah. This transaction is get blocked because there are some error. Yeah. So like I already said before, we have to finish the transaction. Either it is success or either it is failure. Yeah. We have to finish the transaction. So whenever you call any transaction, don't forget to put commit and also rollback if it is needed. Yeah. For example, in this one, when our transaction is failed, I need to put rollback. When I don't call any rollback here, the transaction is still like ongoing. Yeah, it is not finished. It is not closed. Yeah, it is not resolved. So we cannot edit. We cannot select the same row. Yeah, the same row in this table. But what if we select the different ID? Okay, so it is still blocked. Whenever we are selecting other table, it is still getting blocked. Yeah, so this is a table level lock. Yeah, I think. So how to clear this one? So we can roll back. We can roll back the transaction. Yeah, we can call rollback here. Yeah, and then we call the rollback. Then after that we can select this one. Nah, this one ya. Still already finished ya, not done. Ya, not done. Okay. All right ya. And then the same goes also whenever if it is not error, whenever it is not error. For example, when I change the topic ID into 7, for example. Yeah. Um, so if I call this transaction, this is success. Yeah, this is success. So this is what I mean by MVCC. Yeah, multi-version concurrency control. Right. So this transaction is still not closed. This transaction is not finished. Why? Because I'm not calling any commit and rollback. Yeah. So, but because this transaction is success, so I will still be able to call this one, the select data. Yeah. Nah, see, yeah. The data is like this one. Yeah, done. Yeah, still done. Yeah, already changed into done. Okay. But when I call rollback, the data will be back into the original state. Yeah. It is become already finished, right? Okay, so this is how the transactions is work in the PostgreSQL. Hopefully, it will be good for you. It will give you some understanding about how we use transaction in PostgreSQL. So thank you very much for your time in watching this video. Inshallah, we will see you again in the class, yeah, because today you have some agenda, right? So we cannot meet in the classroom. So hopefully we can meet again in the classroom in next week. So thank you very much, students. And I'm sorry if there is something you don't like from me today. Yeah. Inshallah we will meet again next week. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.